chapter 25 is about capacitors. Capacitors are very important electric components that are almost every circuit we're using, from the mobile to the radio, has capacitors. Okay, the capacitors are used in computer memories, in tuning the radio and television transmitters and receivers, and filters, filtering signals, and so on, and in energy storage devices. For example, the defibrillator that they use for saving the lives of people who have a heart attack, that's based on a capacitor. Okay, and they come in different sizes and shapes. Okay, so these are cylindrical capacitors, some of them are parallel plate capacitors. There are even capacitors that are variable capacitors, like resistors. They can be variable resistors. Okay, so a capacitance, the definition, the capacitance C of a capacitor is defined as the ratio of the magnitude of the charge on either conductor to the magnitude of the potential difference between the conductors. So if we have two conductors, for example here, any two conductors, and the conductors are charged, one plus Q and minus Q, so what positive charge, net positive charge on one and net negative charge on one, and they are separated, they are not touching. There is an insulation between them, either air or a dielectric material, something that is an insulator. Then we can write that capacitance C is equal Q divided by delta V, the charge on the capacitor, okay, Q, divided by the potential difference. So whenever we have a potential, remember, a single charge will create a potential. So if we have many charges, they will create a potential. So here we have a potential difference between these two plates, that is delta V, okay, and we have a charge on one plate is Q and another plate is minus Q. The capacitance is just equal to Q divided by delta V. Okay, so this is again, we can rewrite the equation. We can write it Q is equal CV or C delta V. In electrical engineers, they use CV. They don't do delta V. Usually, the potential is a potential difference, delta V. So try to forget a little bit the electrical engineering instead of CV, and we use Q is C delta V. Okay. The capacitance, the unit of capacitance is a farad, and 1 farad, and you can see from the equation, the capacitor is charge divided by delta V, which is coulombs per volt. So 1 farad is 1 coulomb per volt. Okay. So how do we connect capacitors? Usually we connect capacitors to a circuit. Here we are showing a simple circuit, okay, where we have the capacitor plates are shown, and we have conductors, wires. These are very low resistance. They're connected to a switch, so we can close or open the switch, and the switch is connected to a battery, and so on. So the positive terminal of the battery is connected to one terminal of the capacitor or one plate of the capacitor, and when we close the switch, the negative terminal is connected to the other plate of the capacitor. In electrical engineering, we don't draw these components. We draw the symbols for these components. The symbol for a capacitor is like this one. It's two lines that are parallel to each other. Okay, and in this course we will use a non-polarized capacitor. That means doesn't matter which way you place them. For electrical engineers, you have to be concerned. If it's a polarized capacitor, it has a positive and a negative side. But in this chapter, we will use non-polarized capacitors. The battery is symbolized by this symbol, the battery. So we have a long line and a shorter line separated by a small distance, and we write the positive sign on the positive side of the battery and negative on the negative side of the battery. This is how we draw the switch. Now the switch is open. Means there is no current flowing in the circuit. Okay, and when we close the switch, there will be current flowing, and we will see that short. Okay, so what is the battery? The battery is a device that maintains a certain potential difference between its terminals. For example, the car battery gives you 12 volt across its terminal, and it's connected to everything in the car. Okay, a radio can run on, for example, an alkaline battery. It can be, for example, 1.5 or 3 volts, or even 9 volt battery. So a battery maintains constant potential. Obviously, many batteries, or most batteries, are chemical. So after using certain time, the voltage will drop, and that's when you have to change the battery, because it's supposed to give you a constant voltage, but the voltage will degrade with time, and usually you replace your battery with a fully charged battery. Obviously now you're using the mobile, you have chargeable batteries, so you can connect them to the outlet and recharge them, so you don't have to throw the battery whenever it expires. Okay, so this is how we draw the circuit. This is a battery, capacitor, and open switch. If we close the switch, this is how we draw it. Okay, and so the switch is closed, and when the switch is closed, now normally currents can flow or electrons can move around the circuit. Okay, so